Noble.
Noble gas creation.
Hi guys, that was my 2-year-old. He wanted to participate. So, as he said, we're going to talk about noble gas configurations today. And what that is writing electron configuration using noble gas notation. The noble gases are found here in group 18, and they consist of all of these elements. What we can do is we can replace part of the long electron configurations written with the noble gas configurations. The rule for writing noble gas configuration is very simple. You take the noble gas immediately preceding the element you're writing. And I will show you what that means. When I say preceding, I'm talking about the element in group 18, which is this group over here. Okay. And I'm talking about the one that comes before the element or atom that you're trying to write the configuration of. So for example, if I was looking for the noble gas of that was preceding magnesium, which is right here, magnesium is number 12, well, preceding would be number 10, which would be neon right here. Another way to think about this is you would just go up a row and over to this group 18. So if I were looking here at strontium, I'm just going to color in the whole thing, I would go up one row. So I go up a row and all the way over to this row, so it would be krypton. After you found the preceding noble gas, you would write the abbreviation in brackets, and then you write the rest or the other electrons. And you would write the other electrons in the same configuration that you would write the other normal electron configurations in. Okay, so you might be wondering why we call this group over here the noble gases. The reason why we call these noble is because they have what we call a full octet of electrons in their outer shell. That means they have a full 8 electrons in that outer shell. And because of this, they are very unreactive. They have all of the electrons that they want. And most of the chemical reactions that happen in chemistry is so that other elements, all of these over here, that are not a part of the noble gases, can obtain or get that full octet. We're going to do a few examples. You notice that down here I have the Aufbau principle. It's a little bit different than the diagram we had. Maybe it will be more helpful to some of you because it shows you the diagonal rule and kind of how the order goes. So we start at 1s, go up to 2s, we come back up to the next line and go up to 2p, 3s, and we keep going until all the electrons are configured. So I'm going to start with silicon, which is right here, and it's number 14, which means it has 14 electrons. So I'm just going to write out the Si. And I'm going to write out the full electron configuration first, which is what we did last week, to compare what the noble gas will look like. So we start at 1s right over here. And like I said, I have 14 electrons that I need to configure. So 1s will hold 2 of those electrons, 2s will hold 2 of those electrons, 2p will hold 6 of those electrons. So far I've got 10 electrons. 2 plus 2 plus 6 is 10. So I have 4 more. So after 2p, I go to 3s. That's right here. and then it says I go up to the next one and I go 3p, and I only have 2 electrons left. So you notice I have 1s2, 2s2, 2p6, 3s2, 3p2. If I add all of these superscripts, or the exponents as most of you called them, up, you will see that equals 14. To write silicon in the noble gas configuration, we start with that rule and we go to the noble gas that's preceding. So if I go up a row and over to the noble gas, we'll see that neon is my noble gas. So what I would do is I write neon in brackets, NE, just the abbreviation. That neon abbreviation takes up 10 electrons from silicon. So it's actually going to take up this portion right here, because 2 plus 2 plus 6 is 10. So the rest of the electrons, or the other electrons, are going to start at 3s. So it would be 3s2, 3p2. This would be the noble gas configuration for silicon. We would write Ne, which is our noble gas, and then 3s2, 3p2. This is a shorthand way of writing electron configurations. It also tells us that these other electrons that are found out here are our valence electrons. So it actually makes it really easy to find how many valence electrons and where they're located. So for example, we would have 4 valence electrons here, and they're located in the 3rd energy level. I'm going to go through another example, and this time I'm going to use calcium, which is Ca, and Ca is located right here. So the first thing you have to do is find what is the noble gas that is preceding. If you go up a row and over to the noble gas column, you'll find out that it is argon. So we write argon. And here's kind of where a little trick might come in. So the last one, we had already written out the full electron configuration for silicon, but for this one we didn't do that. So there's actually an easy way to figure out where to start the rest of your other electrons. The way that is you look at what row the element that you're looking for is in. Okay, so if I look at here and I number real quick all my rows, you'll notice that calcium is in row 4. So because calcium is in row 4, I'm going to start at energy level 4, which is right here, and I'm going to start at 4s. So 4s is here, okay? Argon configured 18 electrons, and calcium has a total of 20, okay, if you look at it, because it's number 20. So if argon is configuring 18, how many electrons are left in order to be configured? If you said 2, you're correct. 20 minus 18 is 2. S can hold 2 electrons, so I would put my 2 right here, and that's it. So the electron configuration of calcium would be Ar 4s2. Okay, let's try another one. Let's try tin. Okay, tin is located number 50 right here. The abbreviation is SN, and the reason for that is because it is Latin. And to follow the rule, we have to first find the noble gas that's preceding. So again, we go up a row and over to the noble gas column. So we're going to start with krypton here. So I'm going to write krypton in brackets, the abbreviation for krypton, which is Kr. Okay, Kr is configuring 36 electrons, but tin, if we look at here, has 50 electrons. So I need to configure 14 more electrons. Where did I get that number? I took 50 minus 36 and got 14. So I need to now do the other electrons, okay? Using the off-bow principle, which is this, I have to look at where to start. I'm not starting with 1s anymore. I'm going to look at the row that tin is in. So tin, if we take a look, tin is in row 5. So where am I going to start for my other electrons configuration outside the bracket? I'm going to start at 5s, okay, which is row number 5. So what I do is when I start at 5s, and then I continue following the diagonal rule. So I would start at 5s2, okay, so that was, I had 14 more electrons, which are my other electrons, all right, because I already had 36 electrons that krypton is replacing. So after 5s, I go up, I follow this little line, and now I'm going to 4d. D, we know, can hold 10 electrons, and I still have 12 more. So I'm going to put all 10 that are there, okay? So far, of my 14, I've configured 12. So after 4d, I have to go to 5p. So I go 5p, and I only have 2 more electrons to configure. So if you take a look here, okay, my 14 more electrons, I have 2 plus 10 plus 2, which gives me those 14. So the noble gas configuration for tin would be Kr 5s2, 4d10, 5p2. Let's try one more to see if you're getting it. We're going to try manganese, which is Mn, and it's found right here. It's number 25, okay, which means we have 25 electrons that need to be configured. So first question, what is the noble gas that is preceding? Remember, go up a row and over to the noble gases. Well, obviously there's no row right above it, but we are going to still go all the way to the end here, and you'll see that number 18, which is argon, is the noble gas preceding. So I would have argon here. Then I need to do the other electrons. So I look at the row that manganese is in, which is 4. So I'm going to start here at 4s, and I have 18 electrons from argon. So 25 minus 18 means I have 7 more I need to configure. So 7 electrons are going to be these other electrons here. So 4s can hold 2 of those electrons, which means I have 5 more. So after 4s, if I follow the little line, I go to 3d. Hopefully by now you can know that D can hold up to 10 electrons, but I only need 5 more, so I'm going to put a 5 right there. So the noble gas configuration for manganese is Ar 4s2 3d5. Now that you have watched the video and hopefully have figured out how to write these, I want you to try these 4: boron, chlorine, platinum, and iodine. I've left the numbers of each row on this periodic table and the noble gases that are labeled here, and you still have your off-bow principle to help you out as well. Once you're done with those 4, take a picture of your work and upload it to today's assignment on Google Classroom. Have a great day, guys. If you have questions, please, please, please ask.